So I'm going to try again today and see if the sound is working now. So basically, here's the big idea. We are going to learn 5 shortcuts today. Again, I want to emphasize, these only work for triangles. Okay, the way that we learned last class period works for any shapes. So if you want to prove 2 hexagons congruent, you've got to get all their sides and all their angles congruent. Okay, if you want to prove 2 triangles congruent, then there are some shortcuts. I'm going to list them up here on the board and just give you a big overview of them, and then we'll look at the notes. So I'm not really going to go with the notes first. So there are going to be 5 shortcuts. You can make this list somewhere if you want. One section is going to talk about 2 of them. The other section is going to talk about the other 3. So the first, these are shortcuts for proving triangles congruent. The first way is called side, side, side congruence. Side, side, side congruence. Basically what this is going to say is if you can get that all 3 sides in one triangle are correspondingly congruent to all 3 sides in another triangle, you don't have to know anything about their angles. Those 2 triangles are going to have to be the same size triangle. And sorry, I normally would have had this out, but this morning was busy with tutoring, so I've been here since 6:50, but I'm not quite completely prepared. So basically, if I have, let's say, 3 sides, blue, green, and yellow, okay? If I put those 3 sides together, and it's not going to matter how I put them together, it's going to make this triangle, right? No matter how I clip them, if I take another blue, yellow, and green, same sizes, and I clip them together, doesn't matter how I clip them, it is going to make the exact same triangle. Would you agree? And so it doesn't matter, they may be reflected or they may be reflected this way or rotated, but they're still the exact same triangle. So I don't have to know anything about their angle measures to know that the 2 triangles are congruent. So that's our first shortcut. As soon as you have 3 sides congruent to 3 sides, you can stop and say the 2 triangles are congruent by side, side, side congruence. And you can abbreviate it with SSS. If you'll notice on the board, there's 5 abbreviations that we're going to be using today. SSS is the first one. Okay. The second way is side angle side congruence. Now this is super important that you notice where the A is. The A is in between the 2 S's. The A does not come before the 2 S's. Okay, so don't put the A in front of the 2 S's or you're going to use what we call the but postulate. It doesn't work. I'll show you why it doesn't work in a little bit. Please don't call it the bad word postulate. But it is an ugly word and it really doesn't work, okay? So the A has to be in between the 2 sides. And if you're dyslexic or a dyslexic but, it still doesn't work, okay? So if you read it this way or this way, it's still not going to work. Whether the A comes before the S's or after the S's, these don't work. Okay? So the way that does work is if you have a triangle and one side's congruent to one side, a second side is congruent to a second side, but the angle in between those 2 sides. So if I call this ABC, which angle is in between the 2 sides? B. If B is marked congruent to E. So if you have the angle in between, then the 2 triangles will be congruent. In other words, if you think back to these little pieces I was using, that's saying that if I have a green shape and a yellow shape and the angle in between can't change. So I know for sure that my triangle is like this. And I have another one two sides, but again, the angles are fixed in between. I cannot make them wider or skinnier. They're fixed. They're congruent. The only way to make this triangle is to put the same size along the bottom here, right? Would you agree? And so if the sides are the same and the angle in between are the same, then it is guaranteed that the two triangles will be congruent. So you're only going to need 3 pieces of information instead of 6. All right, the third way, and this is going to come in the next set of notes, is angle, side congruence. This one has 2 angles and the side after the 2 angles, or you can write it this way if you want to think about it backwards, side, angle. Still the same thing. Either the side's coming before the 2 angles or after the 2 angles. You have 2 angles congruent in the side. It is different than this one. Angle, side, angle congruence. Both of them are shortcuts to prove that 2 triangles are congruent, but it's where the side is that makes the difference. Here the side is coming after the 2 angles. Here the side is coming in between the 2 angles. So I'm going to give you 2 pictures over here, and you tell me which one is angle, side. So number 1 or number 2, which one is angle, side? Okay. Should be number 2. This is angle, and where is the side? In between them. If I connect this angle to this angle, the side in between is marked congruent. So this is angle, side angle, which is number 4. This one is angle, but when I connect the 2 angles together, that side is not marked congruent. So it is angle, side. Or if you want to read it as side, angle, it's still coming before or after the 2 angles, no matter which direction you go, clockwise or counterclockwise. Do you see the difference between angle, side angle and angle, side? Because those are often confused. But both of them are shortcuts to proving that 2 triangles are congruent. So for angle, side angle, this would be our picture. And for angle, side, this would be our picture. Okay? And then the last one that works is called HL, and I'll explain that one in just a second. But first, let's talk about angle. Angle is another way that doesn't work. So this doesn't work, and angle does not work. Think about that with me. If I know the angles are congruent, we just talked about transformations. Exactly. In a transformation, when you dilate a shape, does it change the angle measures? No, it only changes the side lengths. So if you know the angles are all congruent, that doesn't guarantee that the sides are all congruent because of dilations. So angle is not a way to prove triangles congruent. I think about it like a blueprint. If you're building a house and you have on your blueprint that you have a 90-degree angle and you have 2-inch walls. When you build your house, those 2-inch walls are not going to be 2 inches high. They may be 10 feet high. But that 90-degree angle is still a 90-degree angle once you build the wall, right? And so the angles don't change in a dilation, but the sides do. So angle never works. Do not ever use it as a reason. Never, ever. Don't cuss at me on your paper. Don't cuss at me backwards on your paper, okay? Don't work. These are our 5 ways that do work. Let's talk about HL. And I'll show you a reason. All right, so here's my reason. I'm going to show you why ASS doesn't work, okay? So everybody look up here with me. So let's say that I know for sure that I have this angle right here. I can't change it. I'm going to hold it real tight with my thumb and my fingers, okay? So this blue and this one on the bottom make this angle. I can't change that angle. Everybody with me? So I have angle, and then let's say I know for sure that the blue side's congruent to another blue side, and that this dark orange side is congruent to another side. So that I have angle, side, side. Are you with me? Okay? So without changing this angle, I could have, let me put this together, and now my angle's fixed. This triangle here, or I could have this triangle. So if I don't know the bottom length, but I know this angle can't change, this side and this side can't change, do you see how there's two possible triangles that could be formed? Okay, so angle side side does not prove that two triangles are congruent because there's technically two possible triangles that you could end up with. And you'll talk about this more in pre-cal when you talk about the law of sines and the law of cosines. And they'll talk about how there's two possible situations if you have angle side side. And you'll find those two possible triangle measurements in pre-cal. So something to look forward to there. But angle side side works if it's one special kind of triangle. So now, back to the same picture, let's say that this angle is a right angle, okay? It's a right angle, and I have a side and a side. Now, my side would have to be longer here for this to make sense. So pretend that this side's much longer, okay? But if I have a right triangle, and I know this side and this side, because of the Pythagorean theorem, that side squared plus side squared has to equal the hypotenuse squared. The only triangle that would be possible is the one that would be formed when this comes down and meets here. So if it is a right angle side side, then it works because there's only one possibility due to the Pythagorean theorem. So we don't call it angle side side because then that would confuse us about which triangles it works for. Plus, we don't want to write bad words all over our paper. So instead of calling it angle side side, we use the names of the sides in a right triangle. So angle, side, side. You guys with me? How that's still angle, side, side? But what do we call this side in a right triangle? Hypotenuse, which is H. And what do we call the other sides of a right triangle? Legs. So this would be the leg. So it is hypotenuse, leg congruence. You still have to have three things: the hypotenuse, the leg, and a right triangle. So you still need three pieces of information in your proof. You'll have to show me that you have a right triangle, and then you'll have to show me that the legs are congruent, so you'll need another triangle. That's also a right triangle, where the legs are marked congruent, and the hypotenuse is marked congruent. But you only need one leg and one hypotenuse. It's going to look like angle side side, but you're not going to put angle side side, you're going to put hypotenuse leg. And it only works for what kind of triangles? Right triangles. Okay, that is really these two sections kind of in a nutshell. There are 5 shortcuts that we're going to use. And I just wanted to show you some visually why they work and don't work. Now let's go to the notes and actually try some problems. Okay, so first of all, the first vocabulary word that's in this section is the property of triangle rigidity. Triangle rigidity gives you a shortcut for proving two triangles congruent, and basically what triangle rigidity says is if the side lengths of a triangle are given, which is where we started today's lesson, side, 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 then there's only one triangle that can have that shape, and that's called triangle rigidity. If you have 3 sides congruent to 3 sides, there's only one possible shape that can be made, and that is that specific triangle. Using that triangle rigidity concept, we have our first shortcut, side, 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 and we can just put SSS, okay? And I've already talked about it over here, so I'm just going to go through it pretty quickly over here on the notes. Just a reminder of a property that we used last class period. If adjacent triangles share a side, you can prove that side BC is congruent to side BC using what property? reflexive property. Okay, so don't forget that. That also works if they share an angle. If they happen to have an angle in common, then you would say that that angle is congruent to that angle by reflexive property. All right, so now we're going to jump into proofs, and some of these are going to be super easy and some of these are going to be a little bit harder. I'm going to have you just go through a couple of different ways we can work these. So if it just says explain, I'm not going to make you write a 2-column proof. You're welcome to, but I'm going to tell you that if it just says explain, you can list what's missing and then tell me how you know the two triangles are congruent. So if I want to use side, side, side to prove these two triangles are congruent, I've got one side congruent, a second side congruent, and we just said, how will we know that BC is congruent to BC? Okay, you need to write that down then. On your homework, you would say, BC is congruent to BC by reflexive property of congruence. That gives us 3 pieces marked congruent, so now why are the triangles congruent? Side, side, side. So you would say triangle ABC is congruent to triangle DBC by side, side, side. You can put the congruent symbol after it. Most books won't. Most of them will just put SSS. Okay, so if it says explain, I'm not going to require you to write it out in a full 2-column proof. You just need to list what's missing and how you know, and then use your write your triangle congruent statement and tell me how you know they're congruent. Are you guys with me there? Okay. Here's the next one. Again, it says explain, so we're not writing a full proof. What's missing in our explanation? Okay, I'm going to throw a curveball at you here. It's not going to be AC is congruent to AC. So remember when we talked the other day about making sure we're matching it up correctly? Okay, so it is going to be AC that's missing. Everybody agrees AC is going to land on top of itself. But notice the sides that are congruent. What are we going to have to do to one of these triangles before we can fold it and make it land on it? We're going to have to flip it, right? So really, this angle A, when I flip it, is going to land on this C. Do you guys see that? So really, AC is congruent to CA. And so I'm going to ask you to write it correctly so that you're matching up the correct parts. So sometimes you're going to have to flip your segment over. AC is congruent to CA. You're still saying that this line segment's congruent to itself. You're just naming it so the parts match up. Are we clear? Okay. And so what's my reason here? No, not yet. What is my reason for this? Reflexive property of congruence. And then we can say triangle ABC is congruent to triangle CDA by, yes, side, side, side. Okay? Any questions there? E? Yes. If we're proving two triangles congruent, if that's our goal, now some of them the homework might go a little further, but most of them are going to be just proving triangles congruent. Next class period on Friday, we're going to go beyond proving triangles congruent, but it'll be 1 or 2 extra little steps. But most of them are going to be just prove these two triangles congruent, and your reason for the last step will be one of these 5. We are no longer using the definition of congruent polygons. That's the long way. We do not want to do it the long way anymore. We want to do it the shortcut way. Okay? All right, moving on. When I told you it mattered where the angle was, they call the angle the included angle if it's the angle in between the two sides. So the included angle is the angle formed by 2 adjacent sides. 2 adjacent sides put together, this is the included angle. Okay? And we need to know that for the next one, which is side angle side. already talked to you about side angle side, very important. The way I think about it is when I draw this side and I draw this side, where do they meet? If that angle is marked congruent, then that's the angle in between the two sides. And again, caution, they're in this order for a reason. Don't rearrange the letters or you're spelling bad words, whether you're dyslexic or not. Okay, again, this is just an explaining problem, so I'm going to go through it pretty quickly. How many things do we have marked congruent in this picture? Two pairs of sides. So this one says use side angle side to prove that they're congruent. What angle would be the included angle? C. And why do we know that this angle is congruent to this angle? Exactly. Now when you name it, make sure you name your angle with the correct letters, because you can't call it angle Z since there's more than one angle Z. So we can call one of them what? Angle XY, and it's going to be congruent to. Good. So you started here at X and went down to the side that had one mark. So you want to start over here and go down the side that has one mark. So BZ, oops, I forgot my angle symbol, don't do that. Angle BZW, and this is by what theorem? Vertical angle theorem. And then we can say, based on our markings, we have side angle side. So we can say triangle XYZ is congruent to triangle VWZ. And the reason is side angle side. Is this making sense? Shortcuts, pretty easy. Okay, but again, if it says explain, you have to list what's missing, why it's missing, the triangles that are congruent, and how you know. Okay? Oops, I need to hold up. Am I going too fast? I'll slow down. And then what should be next is some proofs. Is that correct? Or we have one more explain? Okay. I'm going to skip the next explain because it's just the same ideas. Again, what would be what's missing on the next one? And why is that side congruent? Which side would we need for side angle side? I've got side and angle. What side would I need for it to be side angle side? BC. Why is BC going to be congruent? Reflexive property. Would it be BC is congruent to BC or BC is congruent to CB? Yes, because if you look, the sides that we want to match up are right across from each other. So when we fold that across, this B lands on this B, this side lands on this side, so BC matches up with BC. So that would be reflexive property of congruence. And then why are the two triangles congruent? Side angle side. I should save myself time there by just writing it there. Is that okay? Questions? Okay. So if we look at the next one. Oh, sorry, I forgot about these. So this is also a showing problem. It is not a two-column proof. So if it says show, you do not have to write it in two columns, but you do have to still back up and explain what you're doing, how you know. So it says show that the two triangles are congruent for the given value of the variable. Prove these two triangles are congruent when y is equal to 4. So here's our picture. When you look at this picture, what's being given to you? Sides or angles, and how many of each one? Okay, so we have one angle here, T, and then we have this side, UT, and this side, ST, right? And then we're over here in this picture, we're given this side, VW, this side, XW, and one angle, W. So which ones of the two that we've learned so far would we be using here to try to prove? Side angle side, and we agree the angle is in between the two sides, right? Okay, so what we're going to have to do is plug in the W, show your work, because it's all about showing, it's not about the final answer, detailed in neatly, and then prove that you have two sides congruent and one angle congruent. Okay? So we'll start with trying to find one of our sides or angles. I'm going to go with UT first. Label what you're finding. Don't just put a bunch of numbers down on your paper or I'm not going to give you credit. UT is equal to y plus 3. Plug in the value of 4. So UT is equal to what? 7. Again, it's all about showing, so don't try to just jump down and write answers on your paper. You have to show your work. If UT is 7, what does that mean about which two sides have to be congruent now? Okay, be careful when you name it. UT is going to be congruent to, should actually be what? XW. Okay, so you're going to show your work, and then this is what it tells us. UT is congruent to XW. So I'm going to do that first. Then I'm going to come over here and do it for another side. What side do we want to do next? ST. So ST is going to equal 2y plus 3. Plug in your 4. We get 2 times 4 plus 3. What do we get for ST? 11. So that's going to tell us which two sides are congruent. Okay, ST is congruent to V. Is it WV or VW? Good. Is everybody following so far? Okay, we have one more angle to find, or one more part to find, and that's our angle. So what angle are we looking at? T. Don't forget to put measure of angle T since we're using numbers. Measure of angle T equals 20y plus 12. Plug in your value of 4. Show your work. What do you get when you do 20 times 4 plus 12? 92 degrees, which means which two angles are congruent? Angle T is congruent to angle W. And now that you have shown all three parts are congruent, again, notice I'm listing my correct notation, then I can say triangle STU is congruent to triangle VWX by what? SAS. So explain or show are going to require, Kenya, make sure you don't sleep through class, bud. Sit up, pay attention, okay? I know you're tired. So we want to make sure that we are writing everything down correctly so we don't miss points for notation. So again, I want to point out, no line segments up here when I'm using equals. Do include line segments when I'm using congruence. Everybody with me? Okay, now we're ready to do some proofs. So if you look, there's 2 proofs left in the notes for this section, and then we'll move on to the next section. We may do one here and then go to the next section and come back if we have time here. So I want to be able to go through all the ones in the other section as well. So let's try this one first, and then we'll probably skip the last one and come back to it after we do the next lesson. First of all, there's a typo here. This should have a line segment above BC and above AD. Anytime you're saying 2 line segments are parallel, you have to have line segments. We'll start out the same way as we did yesterday or last class period. Write down your given. So first of all, BC is parallel to AD and given. Again, I'm going to separate out my givens because I think that it helps me make sure I know what each one tells me. Go to your picture. Remember, you have to draw the picture. I'm checking your work and looking to see, did you draw the picture? Draw the picture. Mark the picture with what they've given you. Because I specifically said it in class, last class period, that you had to draw the picture for every proof that you do. And you have to mark the picture with what we're drawing. Did I not say that in here? Okay. If I didn't say it in this class, I'm sorry, I won't count off this time. But starting from here on, I said it in my other classes. I must have forgot since you guys were the first one I teach. So sorry about that. Thank you for calling me out on it, though. I won't count off this time, but for today's lesson, are we clear? From here on out, every proof you do, you have to draw your picture. Okay? So draw your picture, mark your picture. The only thing I know right now is that these two lines are parallel. They've added in these markings, but I haven't written that down yet. If these two lines are parallel, then this is my transversal. What could I say next? That is, we do not know that line segments are congruent based off lines being parallel. Say it again. Why would A be congruent to C? They're not made by this line and this line and this transversal. Angle A is made by this line, and we don't know that that line's parallel. Okay, there's two angle B's and two angle D's, so be specific when you name them. Angle CBD. Okay, this angle would be congruent to ADB. Does everybody see how you can only use the two lines that they mark parallel? Okay, don't use the ones they didn't mark parallel because we don't know that those are parallel yet. Only these. So let's list it in our proof. Number 2, I would have angle, you said CBD is congruent to angle. Now, how did you name the next one? ADB. And what's the reason that we knew that? Very good. Alternate interior angles what? Theorem. Okay, do you see how we took our given? We thought back to chapter 3, what do I know about parallel lines? And then we marked the parts that were congruent. Mark it in your picture, write it in your proof. Then go to your next given. So number 3, we now know that BC is congruent to AD. Number 3, given. Mark it in your picture. Now I have this side is congruent to this side, which they already had marked, but we didn't have it listed yet. Then think about today. You've got 5 ways to prove that triangles are congruent. You're looking for 3 things to be listed and marked in your picture, not 6. Right now you have a side and you have an angle. Do you see something else that we could mark congruent and back up with a theorem? BD. Okay, BD is going to be congruent to what? Nope. DB, because notice, angle B matches up with which angle? Angle D. So that means I'm technically going to have to flip this triangle over before I fold them across. So line segment BB will actually land on top of line segment DB. So BD is congruent to DB. And again, you're looking to see, where do the angles match up? If angle B lands on angle B, then you keep it the same. If angle B lands on angle D, then you have to flip it. Does that make sense? Okay, so what's my reason for that again? Reflexive property of congruence. Now look at your picture. Which of our 5 shortcuts do we have marked in our picture? SAS. Side, angle, side. Notice this is the angle in between the 2 sides. So number 5 is side, angle, side. And the statement is what you're trying to prove. We always should have that one correct. Triangle ABD is congruent to triangle CDB. Do you see how these are much shorter today versus our 10 and 9-step proofs from the other day? Okay, so you only need 3 pieces. Let's go ahead and jump to 4-6. If we have time, we'll come back and look at that last one. Is it okay if I change the board? Anybody still copying? If it was submitted before class started, yes. Yes. You're making a big deal to us now about not requests. I'm not accepting anything after 8:30 because a lot of teachers are printing them. And if I get busy and don't check it, if it's too late, I may not get it accepted. So, okay, moving on. 4-6. So on these, this is where they're going to talk about the last three that I started out the lesson with. Again, they're going to talk about an included side because remember on these we had a difference between 3 and 4. Where was the side at? If the side is in between the two angles, we call it the included side. If it's after or before the two angles, it's not the included side. The included side is the common side of two consecutive angles. And again, I think about it as if you take the vertex of one angle and the vertex of another angle, and you connect those two vertices, the line that you draw is the included side. So if this angle and this angle are congruent, this is the included side. And so the next theorem that they're going to look at is that angle side angle, where now you have a side in between two angles. And so now we're going to see, so these questions are just going to say, can you prove these two triangles congruent specifically by angle side angle? If you say yes or no, you have to back it up with why you can or why you can't, okay? So notice right now, what do we have marked? Two angles, an angle and an angle. So we need a side in between them to be marked congruent. Can we get the side in between them marked congruent and back it up with a theorem, postulate, property, or definition? Reflexive says they have to be the exact same side. Is this side the exact same side as this side? Okay, same side means that they land right on top of each other. So does this line land on top of this line? No. So they are not the same side. What is the piece that's the same side? Okay. What side is the same side? The line in the middle. Make sure you're focused with me. This side right here, we could say is congruent, right? Why would that piece be congruent? Reflexive property. So if this were my homework question, number 1, I'm going to need to draw this picture. Number 2, I could write right here that this is congruent. You don't have to write it out because there's no letters. You could just mark it and say reflexive property of congruence. But does that give me angle side angle? No. Hold on just a second. Does this markings that I have marked, this angle, and this side, does that give me angle side angle? No, because this side is coming after the two angles. It is not in between the two angles. So would this prove those two triangles congruent? Not by angle side angle. Would it prove the two triangles congruent? Yes, by angle side. But this question said, can you prove them congruent by angle side angle? So your answer is going to be no. You only have angle side. So you could mark it and you could say no because, and then you're going to have to decide how you want to word that. I might be able to say no because we can't get the included side congruent. Or you might say no because it is by, and mark that reflexive property and then say angle side. But you're going to have to explain some way why it's not. Ooh, good, Bryson. I wasn't even thinking about that. You are right. This is not no. Way to go, Bryson. Okay, so is everybody with me, first of all, that this is not angle side angle yet? Okay, now go with Bryson. Bryson, say what you said. Okay, that's important because there are some tricky ones like this on the test. So you need to think about everything we've thought about and mark everything you can mark, but only if you can back it up with a theorem. Don't just mark something and go, oh, I think they're congruent. That's not true. Back it up. So Bryson is correct. This would be third angle's theorem. This would be reflexive property. So now do we have angle, side, angle? Yes. So this would be yes. And your explanation would be what you have drawn and marked on your picture. Okay, very good, Bryson. Thank you. All right. Okay, look at this one. Let's go with this one. We're going to have to speed up so we can get through everything before we're done. So quickly with me here. Angle, side angle. Look at the picture. We only have one thing marked and it's parallel lines. What else could I mark in this picture? Okay, I heard you say line segment in LY. Has nothing to do with parallel lines. Reflexive. Property of congruence. I'm going to say this again and emphasize this again. If this is a homework question, you are drawing this picture. You are marking what you're saying is congruent, and you are writing out to the side why it's congruent. Okay? I've got one side congruent. What else can I mark, Remy? Did you say KLN? Okay, is congruent to what? Except it wouldn't be LNM, it would be MNL if we're actually naming it correctly. So yes, why? This is my transversal. So these are alternate interior angles theorem. So now we have an angle and a side. Be very careful. Biggest mistake I see students do is they go, oh, angle, side, angle. You can't jump from one triangle to the next. You have to look at one triangle. In this one triangle, I only have an angle and a side. In this one triangle, I only have an angle and a side. Can I get anything else marked congruent? Hannah? And why would those be congruent? Be careful. Those are made by these lines. If you're trying to use this angle right here, it is not made by this parallel line to this parallel line. It's made by KN and LM, and we do not know that those are parallel. Remy? Anybody else have an idea? All right. This one is no. Okay? So this one we only have one angle and one side, and we can't get anything else congruent. So again, draw your picture, mark your picture, and that'll be your explanation is by what you've marked and that you don't have enough information. Okay? All right. The last one here before we get to HL is angle, angle, side. Again, that can come after or before, just not in between the two angles. So here's angle, here's angle. This would be the side in between. If it's not marked congruent, it's not angle, side, angle. It is angle, angle, side. And this I'm just going to skip it. That's just a proof of that theorem. So now we're going to hit a proof. Okay. So now we're going to try a proof using angle, angle, side. So did I give you a statement and reasons box? No, draw it in that blank box to the side. Okay. So first thing we're going to do, draw the picture. X, Y, V, C, W. Next thing I'm going to tell you to do before you write down your given is to look to see which two triangles are you even trying to prove congruent. Okay, so go up here, X, Y, Z, and V, Y, W. I would find those triangles first. X, Y, Z, that's this one. And I'm going to redraw it separate from my picture then. X, Y, Z. And what other one? VYW. So that's this triangle, WVY. Okay, just to make sure we're clear about what parts we want marked in what triangles. Then we're going to go to our given, and we're going to write down our first given. Angle X is congruent to angle V. Given. Then we're going to go to our picture, and we're going to mark angle X congruent to angle V. But I'm going to do it in the ones, I'll probably do it in both, but I'm going to do it for sure in the ones where I've separated. But it might help me sometimes if I'm looking at it as a big picture as well. So I'm going to mark it in both places. That's giving me one thing congruent. Moving on, number 2, angle YZW is congruent to angle YWZ. Given. Then come over to your picture and mark those angles. YZW. I can't mark it in this one, but I can mark it up here in the big one. YZW. So notice this angle is not in the triangles that I'm trying to prove congruent. So be careful. And it is congruent to YWZ. So that's this angle here. That is also not in the triangle over here. Okay? So now let's keep going. I have XY congruent to VY. XY is congruent to VY. Given. Mark it in your picture. XY is congruent to VY. I'm going to mark it in the big picture as well. Okay. How many things do we have marked in the 2 triangles we want to prove congruent? 2. We need a third thing to mark congruent. Any suggestions? Where's a linear pair? Okay, everybody quiet. Go ahead, Malcolm. Okay, so these 2 angles are a linear pair. Does everybody agree? Okay, what other 2 angles are a linear pair? Very good, so these 2 are a linear pair. Okay, what do we know about linear pairs? Okay, the linear pair theorem doesn't say they add to be 180. What does it actually say? They're supplementary. Okay, so that does mean that they add to be 180. But what it actually says is if they're a linear pair, they're supplementary. Okay, so I could say these are a linear pair and these are a linear pair. And then I could say that these are supplementary and these are supplementary. And I've already said these 2 are congruent. We have a theorem that we learned way back that said if you have 2 angles that are supplementary to 2 congruent angles, then those 2 angles have to be congruent. Don't have a supplementary angles theorem. If you don't know, get your book out right now, flip to the back, find your theorems and postulates. It is not from chapter 4. Probably in chapters 1 or 2. Very good, Laurel. So again, the hardest part is going to be knowing your theorems. So you need to spend some time studying your theorems. Okay, so let's write down everything that Bryson and, was it Malachi? Malachi said. Malachi, sorry. Number 4. First thing Malachi said was we have a linear pair. So we have these 2 angles are a linear pair and these 2 angles are a linear pair. We need to start there. So I'm going to name those angles. Angle X, Z, Y, and angle W, Z, Y are a linear pair. I'm starting with the ones on the left. So X, Z, Y, and W, Z, Y. Everybody okay with that? because a proof is all about backing every single step up with a theorem. It's not about getting to a final answer. It's every single thing has to have a way to prove it. Okay? Next, we had another linear pair, angle VWY and angle ZWY are a linear pair. How did we know, Malachi, that those are a linear pair? What's my reason? Okay, so what's my reason? Definition, theorem, postulate, property. Definition of linear pair. The definition says that they are side by side and form a straight line. They're adjacent and they form a straight line. So definition of a linear pair. Okay, then after you told me they were a linear pair, what did we say that means about them? They're supplementary. So now we're going to rename those same angles, but we're going to say are supplementary. So instead of trying to look up here and copy down everything I'm writing, look at your paper and just rewrite it, but now say they are supplementary. So angle XZY and angle WZY are supplementary, and angle VYW and angle ZWY are supplementary. And what told us that? I mentioned it. The definition says these are a linear pair. What tells me that if they're a linear pair, they're supplementary? Nope, that's going to tell us that the angles are congruent in a minute. If they're a linear pair, thank you, linear pair theorem. All right, and then after we said that we had two angles that were congruent and we had two angles that were supplementary to those congruent angles, again, I'm going to emphasize here where that's at. We have this WZY, WZY, and we have this ZWY, ZWY. So we have two angles that are supplementary to two angles that were previously congruent. And the congruent supplements theorem says if that's true, then angle XZY must be congruent to angle VWY. That's the congruent supplements theorem. So now I'm going to mark that in my picture. XZY is congruent to VWY. Now when I look at my picture, do I have three things marked congruent? What are my three things? Good. Angle, angle. It is not the one in between them that's marked, so it's not angle, side, angle. It's angle, angle, side. And we check over here, it's the same thing, angle, angle, side. Doesn't matter if you go clockwise or counterclockwise. You're either going to say side, angle, angle, or angle, angle, side. The books are always going to say angle, angle, side. Okay? And that's what we're trying to prove. Triangle XYZ is congruent to triangle VYW. Okay, we have 5 minutes. I'm going to steal your notes real quick and see what I want to point out before we go on. We're not going to do the next proof today. Let's look at hypotenuse leg. We just got a couple minutes. So hypotenuse leg, I've already mentioned what that is. It has to be for a right triangle, and you have to have the leg congruent and the hypotenuse congruent. And it can be either leg, but one of the legs congruent. So let's look at this example here, and then we'll stop. So when you look here, determine if you can use HL congruence theorem to prove the triangle is congruent. If not, tell what else you need to know. So first of all, do I have two right triangles? Not yet. Do I have two right triangles though? Yes. So you need to mark that this is a right triangle, And you need to tell me why you know that's a right triangle. Good. Linear pair theorem. We know that they both add together to be 90 or be 180, so we know the other one has to be 90 degrees because they're supplementary. Okay, now do I have two right triangles? Bryson, you with me? Logan, with me? Do I have the hypotenuse marked congruent? Do I have a leg marked congruent? Can I mark a leg congruent? Okay, which leg? The middle one. And why? Good. Reflexive property of congruence. So can I prove these two triangles congruent by hypotenuse leg? Yes. So it says if you can't, tell what else you need to know. So you might have to say something like, no, I need a leg congruent, or no, I need the hypotenuse congruent, or no, I need to prove it's a right triangle. So if you don't have a piece, tell what you're missing. If you don't have a piece but you can prove it like we just did, then you're drawing the picture, marking it, and telling me why. Is that clear? Okay, so here's the deal. On the notes, we didn't get to one proof on 4-5. We didn't get to one proof on 4-6. And we didn't get to the last two examples, which are the same as the one we just did. I feel like you should have enough information to be able to do the homework. Here's the deal.